Hello everyone. So in this video we are going to learn how to delete a key in a B plus tree. We already discussed that what is B trees and how B plus tree is different from the B trees. So let us quickly recall that in the B plus tree, the leaf nodes are actually representing the actual records and all the internal nodes are basically the indexes. They are just the key values that can take us to the actual record which are kept into the hard disk. So whenever we insert anything onto the B plus tree, it's always going to be inserted at the leaf. And whenever we find that any node to be splitted, then it will also carry its index to its parent node. So already we have discussed. So let us quickly see the status that how the B plus tree has been constructed, and then we will take some example of deleting a key in the B plus tree. Okay, so quickly we'll have a look at how the operations are performed, means the deletion operations are performed in the B plus tree. And then we will be understanding with another example in a more elaborative way. So this is the tree given to us. It's a B plus tree. You can see that all the leaf nodes are connected with the linked list. So means once you're reaching to this node, we can access all the data elements in this, in this manner with the help of the linked list, because every leaf node contains a link to the successor node. Okay, so these are, you can also see that these are 78 and 78 is written here. So this is actually representing the record which is in the hard disk, and this is basically the key. It's a kind of indexing that we are maintaining to retrieve this record. So also we see here that the successor element is basically representing the record. So if you look at the 10, the successor of 10 is this thing, this node. So this is the key and this is the record. So the successor of 20 is this. So this is the key, this is the record. So for every node, you can see that this element, if represent a record, then the predecessor will be its key here. So you can see here, 78 is the key and 78 is the record, which is here the successor. Okay, so now we are going to delete 20. So 20 to be deleted, this is to delete 20. So 20 is here. So whenever we delete any, so the very first thing is we need to search that where that record exists. So we know how to locate that. So we know that 20 is here. So this need to be deleted. Now, when the record is deleted, then there is no sense of keeping its key, because key is an index that actually take you to that location. But now if the 20 is not existing, that means this key has also no need to be existing here. So we will be deleting this particular record from the node, and then we are going to check that deleting after deletion, that the property of the B plus tree is existing or not. So we know that after deletion, at any point of time, the tree must maintain m by 2 uh, links and m by 2 childs at any point of time. So if we delete this node, so you can see now this is actually the tree of order 3. Order 3 means that and the maximum 2 keys can be existing or possible at any point of time, and it can have maximum 3 links, and minimum requirement is that it can maintain, every node must maintain 2 links and it must maintain 1 key value. Okay, so being 20 is the only key here, so it is going to make this node empty. So it will look to the sibling, that which sibling is going to help. In the help means it is a sibling contains some extra key value uh, that can provide it to this node so that it can fulfill the requirement. So we have 20 here, we have only one value. Now we look to this, that we have 78 here. Now 20 is to be removed, this is to be noted here. Now 78 to be shifted here. Now when 78 is to be shifted, that means when this uh, record is being shifted, that means its key has no more has a meaning, because this key basically represents this record. So once you shift this 78 here, then now this to be adjusted and this to be adjusted. This represent the key, this represents the key, and the successor of this key must be the record. So now you find here 78 no more, 78 is no more here. Now 78 is here. That means this key must represent this particular record. So this must be 78 and this is now 90 here. So this record must be linked by this key 90 here. So we will get 78, 90, and 78 comes here and it will leave here only 90. So we are done with deletion 20. Now delete 10. So delete 10. So we are actually here. So when we delete 10, we will get this structure. So this is our tree after deleting the 20. So when you delete 10, so 10 is this actually, you can get that 10 is actually this particular record is existing here. So now this is to be deleted, and also we need to update this particular node, means this particular key, because this represent this record. Now let us see what is going to happen. Now when we delete this, it is going to make this particular node empty or a vacuum which is not permitted. So it will look to the left sibling. There is no left sibling. Then you look to the right sibling, the right sibling existing, but it has only one value here. So if this value is passed here, then this becomes empty, which is not permitted. So only in our case, because this is of order 3, if any node contains two values, then only it is possible to provide one extra value. Otherwise, if it is less than two value, then node cannot provide the value to make it balanced. So what is going to happen? So whenever the sibling is not in a position to provide any of the value to make it balanced, then it will look to the parent, and then parent need to be kind of pulled, and the siblings need to be merged together. So so this is going to be merged, and now there is no more meaning of the 78, because we are going to merge it here. So we are going to replace this. Now you can look at a scenario. Now this becomes one node whose value is 78. So that means we need also one key that can uh, connect this record 78. So now this is going to be 78 here. So now you can see this is the structure. This is 78. This is no more existing because it is being pulled here, and this is merged, and this is 78. So now you can see that this key value, the successor, is actually pointing to its own record. Now delete. So 10 is deleted. Now the next to delete is 6. So now this is the tree that we are actually in our hand, and we are going to delete 6. So 6 is here. This is 6. This is key. This is record. So now just make a note that this is to be updated and this is to be deleted. So when this is deleted, it makes a vacuum here. So now we will look to the sibling. This is sibling which has two values. Okay. So then this is going to be passed here, and now 5 is no more here. But when 5 is passed here, so we need to also maintain it index. So this is 5 here, and this also will be updated with 5. So you can see here, this is the structure that we get. So 78, 5, and all are also linked together. So this is how we finally get our tree. Now let us take one more illustrative example to make our understanding better. So let's start. Okay, so I am using this site, which is a very interesting site where you can practice your insertion, deletion of AVL, B tree, B plus tree. So you can see this is a link that can be used to get this page. Now we are going to construct one B plus tree because we are learning here how to delete the key values in the B plus tree. So the very first thing, we must have some B plus tree with us. So quickly let us construct one B plus tree. Let's say we are going to insert this. Let us find some nodes to be inserted. So let's say 90, 105, these are the key values that we are going to insert. Then let's say 81, then 68. We are just taking any random value here because we need to construct one tree, 20 and 75. So we already learned that how to insert these values and construct a B plus tree. So here we will see that how it can be done. So you can note down these values: 90, 105, 81, 68, 15, 20, 75. Uh, okay, so let's see. 90, we insert 90, then we insert 105, then 81, and this is our order 3 tree. So you can see here. Here it is maintained that this is order 3. So you can also practice for order 4, order 5, order 6, order 7. So we are practicing for order 3, 81. These are the values that I have written earlier. So I'm going to construct a b plus 3. Okay, this is the tree that we have get finally. And now we will see that how to perform the delete operation here. So you can also note down that we are going to delete particular nodes, because when I move to this mode, means when I move to this web page for doing the operation, then whatever I'm writing here, it is not actually visible. It will shift to the other screen. So I'm going to delete, let's say, a 90. I'm going to delete 75 and 20 and 68. So you can note down that these key values to be deleted in our b plus 3. So we'll start with 90. So 90, you can see the 90 is here. So 90 is here. So actually this is to be deleted. And also we need to update its key value with its index, which is in the internal node. So if I delete this 90, that means this is no more has a meaning. So this basically representing the record. So if we delete this 90, this is a degree 3. So degree 3 means we need to maintain. So degree means m is 3 here. So if we talk about the child, so minimum m by 2 seal, that means two keys must be, sorry, two childs, two links must be there at every point of time with every node. And also we must have m by 2 seal minus 1, that is one key must be present. So if you look at this, if we have two values are there, so that means if we are left with one value, then also it is okay, there is no problem, and it is fulfilling or uh, satisfying the b plus 2 requirement. So 90 is going to be removed here, and now 105 is only left here, and because 105 is here, so that means this must be also 105, and we are done with. So let us have a look here. So if I delete 90 in this tree, then what will happen? So you can see here that now this is just change here with 105, and 90 is removed from here. Now the second thing that we are deleting is 75. So let us clean this part. So next is 75. So 75 is here. So this is the 75. It's, you can see the key value at the root, and this is our record 75. So we are going to delete this part, and also we are going to update this. So this updation is to be done at a later. Later means first we will see that what is going to happen here, how we are going to manage this deletion. So maybe this deletion does not affect, or maybe we are going to replace with some other value. So based on that, we are going to update this key value. When we delete 75, this is left with one value, and one value is actually acceptable. So what is going to happen if I do this, delete this, then it is left with 81, and then that means that 81 must be having one key. So this is must be replaced with 81. So we are left with this structure, and we are done. It does not violate any of the properties. So let's see that what is going to happen when we delete 75. 75 deleted, and you can see that we are left with this structure. This is what we have discussed. Now what is next? So we are done with 90, we are done with 75, now 20. So let me clean this part. So when you delete 20, so 20 is here. So 20 is actually you can delete directly, because there is nothing to manage with the key. There is actually also not violating the minimum requirement. So this is left with one value, and one value is acceptable in the B plus tree of order 3. Okay, so let's see what is going to happen. Let us delete this 20. So we'll go here back to this area, to our web page, and we delete 20. And we find that 20 is deleted with no much changes in our tree. And this is what we are left with. Now let's see what is next. So next to delete is 68. 68 is here. 68 is here. So if we delete this, then we have to also update the key value. Now, when we delete 68, we need to see that this is going to become vacuum empty node, which is not permitted. So we'll take help from the siblings. So this node is having only one left sibling is there. There is no right sibling. So the sibling means that comes from the same parent. So from the same parent, we have only one node. This is not a sibling here. This is a successor in terms of the linked list, but this is not a sibling. So this is a sibling which has only one value here. So it is not in a position to provide one value so that it can satisfy the minimum requirement. So it will look to the parent here. So parent is also having only one. So if the parent is having two values, means if we have two keys here, we can just pass it one key to the down node, and we can get our condition satisfied. But parent itself is actually having one value. So in this case, we are going to pull this actually, and then we are going to merge it. This is going to merge together. Now this is also going to become empty here. So we have to fill this space. Just keep in mind, we have to fill this space. Now it will look to the, so now in order to fill this, it is going to look to the siblings here. Now keep in mind, now this value is deleted. It is going to be merged. We are left with 15 here. And this is also to be updated. It will look to the sibling. Sibling has only one value. So again, it is going to merge this. So when it is going to be merged this, so what you will find that this is going to be like, becoming a one node. And we will find the structure like this, that 81 will come here, and the left of 81 is 5, and the right of 81 is 81. And then it also satisfy the condition that 81 will will actually getting its predecessor as an 81, means this 81 key will connect to the successor node as its own record. So let us have a look at what I am going to say. This is actually what I am saying, 81, 105, and here we get 81, and here we get 15, and here we have already 105. Let us have a look here that how it is going to change our tree. So if I am going to delete here 68, so this is the tree that we get finally after deleting all these key values. Let us add some more keys to it, and then we will do some more deletion. So let us insert quickly. And I believe that you know how to insert the keys into the B plus trees. Let's say we are going to insert 525, and then we are going to delete in our tree. Let's say we are deleting 81, and let's say we are deleting 105. This is 105, 81, and also this 81 and 105. And let's also delete 5. Let's see that how these operations are to perform. So quickly we will insert using this particular environment that we are using here. So I'll do quickly. So 525 to be inserted. So insert 5, insert 25. Okay, so we get this tree finally. So let's understand that the first thing we are interested to delete 81. So 81 is here. So this is to be deleted, and correspondingly we have to update this key value. Now, when we delete this, it is only the minimum kind of keys are here. So if we delete this, it will create a vacuum, the empty node, which is not acceptable as per the property of the B plus tree. So it will look to the siblings. It has only one sibling, which itself has not in a position to provide. So sibling, basically that means that belongs to the same parent. So it has only one sibling, right sibling. It looks to the parents. Parent is also having uh, one kind of value here. So it is not in a position to provide something to his child to satisfy the requirement. So we are going to kind of uh, pull it from the parent, and this is going to merge. Means this is going to merge together, and this is no more actually existing 105 is no more here. Okay, this is going to merge here. When you merge, then this is no more as a meaning, because this is just a key for this record. Now this actually creates a vacuum here, which is to be filled. It will look to its sibling. So sibling has only one key, and parent is also having only one value. So again, it is going to be pulled here, and finally we are going to actually merge this together. So actually we will be going to get something like this: 15, 81, and then we have, sorry, 81 is deleted, 15. This is to be updated. So this is actually updated. You can write it as like a blank 15. As I said that this is deleted and this is to be updated 15, and this we have to update it. And then we have 105 here, and then we have 1525 here, and 5 here. Now since this is going to become a successor for this particular uh, value is 105, so that means this is going to be 105. So we will have this structure after doing the deletion of 81. So let us have a look here. So delete 81. And see, we have find that 81 is now no more existing here, and this is merged, and it also just satisfy all the requirement. Okay, so we can do this next to delete is we have decided to delete. Let me check. So next we are deleting 105. Okay, so this is our tree, and we want to delete 105. 105 is here. So if we delete this, this needs to be updated. So this deleting this particular value will become making it a vacuum. So it is going to consult with the sibling. Sibling is having two keys. So okay, then definitely we are going to take this 25 here. And since 25 is coming here, so it is going to update this as well. So this will be 25. So we will be having 15, 25, and 25 is no more here. 25 will come here. And this is our new structure. So let's see that how it is going to work when we delete this 105. So you can see that this is worked in the same way as we have discussed that how the B plus tree will behave. So the last thing that we plan to delete is 5. Okay, so this is our tree, and the last to practice is delete 5. So if we look in the structure, the 5 is here. We delete the 5, and then this is going to become a vacuum. It will look to the sibling. Sibling has only one value. So sibling node, it has only one here, and look to the parent node, and parent has two. So it can be done. So what is required? That now we are going to uh, pull this actually. So when you pull this, it is going to actually now when I say pull, basically this is going to be removed here from here, and this is going to merge together. So merging together means now there is no more an empty node existing, but it becomes one node. So this two node, which is actually one with one value and zero value, now it becomes only one node with one value. And when we do merging, this emerging parent means when we merge the two siblings, then the parent that comes in between the two will no more be existing. So we'll delete this. So finally, we are going to get something like this: 25, 15, 25, and this is our final tree, which is which we get after deleting the node 5. Let's have a look. Delete 5. Okay, so we are getting the same tree that we have discussed. So I believe you have understood that how the deletion has performed, and when we delete any of the values, then how to maintain the keys, how to maintain the properties, and how the splitting and kind of movements between the values have been done. We have checked. You can use this environment to practice yourself. You can practice for AVL trees, B trees, B plus trees, and you can also change the order. We have practiced for uh, B plus tree of order 3. You can check it for order 4, order 5, and then you can do insertion deletion and see the structure, that how the structure has been changing. So when you do anything, when you do the insertion, it will change the structure. So if you know the basics, that how this change has been taking place, if you know the properties, you'll understand the new structure after doing any of the operation. So I believe you have understood all the things. So that is all for this video. Thank you very much.